Hi again, this is Galen Pickett, Cal State Long Beach, Physics 151, and starting off Chapter 4, we've got this problem, this puzzle of Tarzan and his vine. So, let's see what's going on with that. We've got a vine. Tarzan lives in the jungle, he swings on vines, he knows properties of vines, so he can eyeball one and he knows if one is of a particular girth and of a particular species of plant, that it can support his weight. If I look at what the momentum principle says here for Tarzan, if Tarzan is the system, there is Tarzan, his entire mass, I have a tension force upwards, and I have his weight force downwards. Those two things balance because Tarzan is not changing his momentum. I get Tarzan's final momentum is equal to Tarzan's initial momentum plus F net delta t from the surroundings. The final momentum is 0 because Tarzan is at rest. The initial momentum is 0, so the net force has to be 0. That tells me that the tension for the cable, the tension in the vine, is equal to minus the weight. Now this happens as a vector relationship, so minus the weight is a vector that points downwards, minus the weight is one that points upwards. So the tension merely supports Tarzan's weight. Yet when Tarzan swings, so he starts at rest here from some branch on a tree, he's at rest here on the same kind of vine that can support his weight, and when he gets to the bottom of the swing, the vine snaps and he falls. So if I look at what Tarzan does, he swings downwards, the vine breaks, and then he starts doing something else because the vine is no longer contributing to changing his momentum. So why does it break? Well, let's think about what happens. Let me make some dots here showing what Tarzan would do if the vine did not break. So here are showing, this is the breadcrumb trail for what Tarzan is doing coming in before the bottom. So here's the actual bottom. So coming in before the bottom, leaving after the bottom. And let's look at this as the initial momentum, and this is the final momentum. So this tells you what is Tarzan's average velocity for this delta time period and for that delta time period. So I've got an initial momentum, looks like so. Tarzan is moving to the side, but he's also moving downwards at that time. The final momentum looks like so. Tarzan is moving to the side, he's still moving to the side, but he's now moving upwards. That's this time. That's P final. So if I ask what P final minus P initial is, I go back to our original construction for how to subtract vectors. I put at a common vertex the final momentum, which is this vector here, and then I put the initial momentum, both at the same vertex, which is this vector here. So I've got the final momentum and the initial momentum. And now Tarzan's momentum, the delta P, points upward. So now if I ask what the momentum principle says, here's the system of Tarzan, M. There's a tension upwards at the bottom of the swing and there's a weight downwards. But now, the tension plus the weight does not add to 0. The final and the initial momentums are not the same. What I have is the change in the momentum is equal to F net times delta t. The change in the momentum is this upwards vector, so I'll just give this a name, so I have delta p is equal to the net force is the tension plus the weight times delta t. So I can divide by the delta t, I get delta p divided by delta t minus the weight is equal to the tension. So now the tension minus the weight looks like so, but I have to add to it delta p divided by delta t. So in order to make it without the vine breaking, I need a much bigger tension. The magnitude of the tension has to be greater than the magnitude of the weight. And if that magnitude gets to be too big, then the vine will break and Tarzan will fall. And that's why the tension force has to be larger than the weight at the bottom of the swing.